Hello, pre-calc. For today's do now, we got a worksheet. You can find the link to it there in Canvas. You should print that or bring it from class and use your calculator. Evaluate those logs. Should take probably not even 10 minutes to do parts 1 and part 2. I mean, if you were in class, you could work with a partner, but you do not need 9 decimal places. So just 3, and you can find the log button there in your calculator. Just log of 3 and plus log of 4, whatever you're supposed to do. Okay, so we're just doing investigation part 1, investigation part 2, look for patterns or connections, and then you can come down to this next row here, develop a general rule. If you can come up with a general rule, it'd be super. You definitely should do this. So you should, at this point, hit pause, print that worksheet, find your calculator, and actually do it in about 10 minutes from now. Hit play again. And I'll meet up with you back here. Okay, well, nice job doing your worksheet. Here's what we're looking at today: logarithms. You probably guessed, since I just asked you to calculate a bunch of logarithms. So expanding and condensing, and that is our learning target. You'll be able to expand and condense logarithms. So why would I ask you to do this stuff with the logarithms? Like, yeah, there's some cool things. Hopefully you notice some cool patterns. To see why I asked you to do the investigation, the historical context, as well as like why we have logarithms and what we're going to be doing in the future with them in the next few days. You should totally watch this video here, which explains where logarithms came from, why they were created. And we watched this in class, but you find the link to this there in Canvas. So hit pause on me, go watch this other video, come back to this video after you have watched that other one. All right, so the investigation. Part number 1, what patterns or connections did you notice? Well, I'm not sure what you noticed, but hopefully you noticed that some of these things have the same answers. And let's think a little bit about why that might be. So I got log 3 plus log 4. And that's the same thing as log 12. I mean, we got the same answer, right? So how does a 3 and a 4 turn into a 12? Obviously, if you add them, you don't get 12. But if we take the 3 and we multiply it by the 4, that would give us 12. And there are several more examples of the same thing. Log 4 plus log 5, same answer as log of 20. If we take the 4 and the 5 and multiply them together, it gives us 20, right? So how about a general rule? Log A plus log B. That'll be the same thing as multiplying A times B. Right? This is actually the reason why logarithms were invented, right? Was to be able to do the multiplication, A times B, rather than multiplying it. Since they didn't have calculators back then, they wanted to say, hey, look, we turn this into an addition problem. We look it up in the log table, boop, 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 blam. We get the thing here for log of A, we get the thing there for log of B, add them together, done, right? As it turns out, there's a whole bunch of other things we use logs for that they did not know when they first invented logs. I mean, it was unintended. Wow, look at that. Like part 2, for example. So here are some answers, and hopefully you noticed, again, some of these have the same answers. For example, log 6 minus log 2 is the same thing as log 3. Why is that? 6 minus 2 does not equal 3, so it's definitely not subtraction that's going on here, but 6 divided by 2, that's 3. Right, so subtracting these two logs would be the same thing as dividing the 6 and the 2. Log of 6 divided by 2, that's where we get that 3 from. And then there are a whole bunch more examples doing the same thing. The next one down, log of 20 minus log of 5. If instead of that 20 divide by 5, it's going to give us 4. And when we look down here at log of 4, we actually got the same answer. So general rule, log of A minus log of B. That is the same thing as log of A divided by B. Super. Nice. Well, what about part 3? I didn't ask you to do part 3, but I'm sure some of you just were like, dude, I'm going to keep going. And you did part 3. Maybe some people didn't actually listen to the directions. You're like, I'm just going to do all the stuff on the sheet. And all right. Well, it's actually good because we're going to need part 3 for today, even though I didn't ask you to do it. We'll spend more time focusing on this next time, but it does actually show up for today. So 3 times log of 2 is the same thing as log of 8. How in the world, that's times that, how in the world do we get 3 times log of 2 to be the same thing as log of 8? Well, if you know mental multiplication, you know your times is your powers. 2 multiplied by itself thrice is the same thing as 8, right? 2 times 2 is 4, and then times 2 again is 8. So 3 2's multiplied by themselves gives us 8. So log of 2 to the power 3, same thing as log of 8, or the same thing as 3 times log of 2. And again, there are some more examples there doing the exact same thing. That next one down, 2 times log of 5. Well, we would have to just take that 2, slide that over here as an exponent on the 5. 5 to the power of 2 is 25. And there's log of 25 down there. We got the same answer, right? How about a general rule? All right, n times log of a, same thing as log of a to the power of n. Cool. So if I take some one problem from each of those 3 parts, there are basically 3 things we need to know. Vocabulary, expanded over here, condensed over there, right? When the people were originally inventing logarithms, their goal was to go from condensed towards expanded. So they could take a multiplication problem like 2 times 3 or something way harder than that and turn it into instead of multiplication, turn it into addition. Okay, well, as it turns out that if we do the inverse or the reverse operation, that also works. So multiplication, the reverse of that is division, and the reverse of adding is subtracting. So there's that. And as it turns out, since logarithms actually are powers, they are exponents, just written in a different way, the same properties of exponents also apply to the as properties of logarithms. And so when you do a power of a power, it's like multiplication, right? So that's where this multiplication comes from. 3 times log of 2 is the same thing as taking the 3 and dropping it on the 2 as an exponent. Okay, there's the same things written in general form. Sometimes seeing with actual numbers makes more sense because you're like, oh, I can see where the 6 and the 2 go together and the 3, and it makes more sense. Where it's just A's and B's, you're like, it doesn't make any sense to me. But here are the general forms that we wrote down. I would strongly encourage you to write down one or both of these versions into your notes. Keep track of this stuff, commit it to memory. And let's take a look at some examples. So the first one, write the following sum as a single logarithm. Well, you know what those directions actually mean? Condense. So condense log base 2 of 7 plus log base 2 of 12. All right. So we got 2 separate logs. They both have the same base. That is super, super important. If they do not have the same base, we cannot do any of this stuff. But we're not going to actually do anything with the base. We just need to notice it's the same in both cases. All right, so log base 2 of 7 plus log base 2 of 12. We can not have this dot. Sorry about that. Instead of adding the 2 separate logs, we just combine into a single log, multiplying the outputs. Multiply 7 times 12. Okay, and then we can multiply 7 times 12, which gives us 84. Final answer. Okay. Expand the logarithm this time. So I got log base 2 of 16 times p. So inside the parentheses there, multiplication, 16 times p. So I'm going to expand that into adding two separate logs. You can put parentheses on them. You can leave the parentheses off. It doesn't actually make any difference. It does look nicer with the parentheses. Reminds us how we're supposed to pronounce it. It's just like function notation, f of x, right? When you see the parentheses, you're like, of, log base 2 of 16. All right, well, so we expanded. Hooray, good job. However, if you were to type that answer into WAMAP, it's going to tell you you're wrong and not explain, but the reason is because simplify. So this one we can simplify. Okay, remember, logarithms, every time you see the word log, just think power. So when we see this first one that I just highlighted, it means what power goes on the 2 that would give us an answer of 16. Or you could even rewrite it. 2 raised to some power needs to equal 16. And then you think to yourself, how many times do I need to multiply 2 together to equal 16? Well, there's 2 times 2, that's 4. Times 2 again, that's 8. Times 2 again, that's 16. So this is 2 to the power of 4 equals 16. Oh, there's too many equal signs there. Okay, so that yellow highlighted part, we can simplify to the power. The power is what we're after here, not all the rest of that stuff. So 4. That whole yellow nonsense there is going to turn into 4. Final answer. All right, another expand. So this time we've got division inside the parentheses. To expand division, I am going to subtract 2 separate logs. And this one also asks us to simplify if possible. So the one with the m, we cannot simplify. I don't know what m is, but the one with the numbers, I might be able to simplify. So I'm going to ask myself those same questions. 6 raised to some power is going to give me 15. 6 multiplied by itself how many times gives me 15? Well, 6 times 6 is 36, and that doesn't work. And 6 by itself doesn't work, and so this does not simplify. There are no whole number exponents that would work to give me 6 to that power to equal 15, right? So I checked, cannot simplify this time. Get rid of that highlighting, and final answer. Woo. All right. Write the following sum as a single logarithm, or condense, we could have said. All right, so these two log base 3s both being added together. So if I condense that, I'm still going to get log base 3. I'm going to take this x and I'm going to multiply it onto that x plus 9. You can use parentheses for multiplication in here if you want. And then you can sometimes get away with just typing that as your answer. And WAMAP will be like, yes. Sometimes it's going to actually want you to distribute so that we don't have all these extra parentheses in here. So we can do that. X times x is going to be x squared. X times 9 is going to be 9x. So final answer, x squared plus 9x. Right, and like I said, sometimes you get away with it either way. It just kind of depends on what teacher wrote the problem in WAMAP and how the answer is keyed in there. So also pay attention to directions. All right, last one. Write the following as a single logarithm. Well, okay, that means condense, right? Whether it says those words or not, that's what we're after. So log base 5 of 6 plus 4 times log base 5 of b. Okay, well, this one, we have not done anything like that yet. So I got 4 times log base 5. That is, oh man, look, I got the wrong stuff typed in here. There's supposed to be an N and an A. So it's like this one, where it's like this one, where 3 times log base 2, I can take that 3 and make it into the exponent on the 2. And maybe, depending on whether I have numbers or not, I can actually evaluate 2 to the power 3 to get 8. Okay, so here goes. With that part highlighted in green, let's do this in 2 parts. Log base 5 of b to the power of 4. Right, and then, whoops, and then I got carried away with the other stuff here. I forgot my plus. Okay, and then 2 separate logs being added, so I can condense those by multiplying inside my parentheses. And also, I'll try to write way neater than that. Log base 5, shoop, shoop, 6 multiplied by b to the power of 4. We can actually read those. There we go. Final answer. All right, we'll have fun.